Okay, so now let's go ahead and move on to lesson 14.3. Okay, of course, you can see the title over here, Constructing Exponential Functions. And don't forget to copy your essential question. What are the discrete exponential functions and how do you represent them? Okay, go ahead and copy the essential question. Ready? Go. Now that you are done, let's go ahead and move on. Okay. So then here is one thing that you have to know. You have to know what discrete means. What is a discrete function? Okay, so a discrete function has a graph consisting of isolated points. Isolated points. This is kind of important. In case you can't see, I'll try and write this for you. Discrete function. I'm basically just copying the same thing. And then, what are they? They are isolated points because vocabulary is, as you know, very important, okay? So what that means is if you were to draw a graph and you see a whole bunch of dots, this is what we call a discrete function, okay? Versus if you were to see a graph and it's not dots, it's a straight line, then we call this a continuous function. Okay, so that's it. Discrete function means you have dots. Continuous function means you have a long line and it's all connected, okay? Nothing mysterious, okay? And then now over here, it kind of the textbook tries to teach you how to create a table, and then after creating a table, putting it on the graph, okay? And this is when this is one of those graphs that you can draw, which is just a straight line. And then down here, they give you another function that they want you to create, another table, that they want you to fill out, and then graph. And this one's going to look a little bit different. So I'm going to go ahead and spend some time just explaining to you how to do this really fast, okay? So this is a linear function. It says the table represents the cost of tickets in dollars to an annual event as a function of the number T of tickets purchased. What that means is they're trying to go somewhere and the tickets cost, I guess, $15 for one, right? And so if you buy 2 tickets, it's going to be $30. And so that's what it is. It says complete the table by adding 15 to each successive cost. It's already telling you that you're not multiplying, you're adding 15. So what you're trying to do is create a table, which is an arithmetic sequence, okay? So let's see. If you buy 0 tickets, it's going to cost you $0. So if you were to put it in an ordered pair form, you'll just put 0, 0 because you have 0 here and 0 there. If you buy 1 ticket, it's $15, so that will be 1, 15. Buy 2 tickets is 30. So then if you buy 3 tickets, it's going to be $45, right? So then I'll put 3, 45. Same thing. If I buy 4 tickets, it's going to be $60. Okay. Buy 5 tickets, I add 15 to 60. This is just like all a pattern, right? So that'll be 5, 75. I check my answer. Of course, I'm right. And then now what we're going to do is you see all these points. We're going to put it on that graph. You see 0, 0. You're going to put that point right there. Okay? Right there. And then if you go back up, you will see 1, 15, right? So then you come down here and then you're going to plot it right there. So here are 0, 0, and then 1, 15. 15 has to be these are in increments of 10. So 15 is like right here. And so on and so forth. So we're gonna have to graph this, okay? And so why am I doing this? Because the textbook already has the answer for me. And obviously you can see that, okay? So there you go. 0, 0, 1, 15, and 2, 30. In between 20 and 40 is 30, right? How did I know it's 2, 30? Because it's right there. And then the next number is 3, 45. So look, it's all dots, right? So this is called a discrete function. Now, this one is another kind of a situation. This one is where the ticket price goes up every single year because, you know, like sometimes you try and attend an event and the ticket prices go up, right? So first year, oh, this is just like, oh, the number of people attending an event. I'm sorry, Miss Choi didn't pay attention when she was reading. So there you go. The first time they had an event, nobody knew about it, so only 2 people came. I mean, 25 people came, okay? And if you put it in an order pair, it would be 1, 15. The second year, they hosted the same event. More people heard about it, and they're like, oh, it's cool. So 50 people showed up. And over here, it says, fill in the missing table entries by multiplying each successive attendance by 2. That means keep multiplying by 2. So this time, we're doing a geometric sequence. So what is 50 times 2? 100. So I'm going to put 100 right there. And so that means I'm going to have 3, 100 as my ordered pair, right? Because it's 3 here and 100. 100 times 2 is 200. So I have to put 200 here as well. 200 times 2 is 400. So I'm going to put 400 here as well. And then afterwards, of course, I check. They're all right. And we have to put them on the graph, okay? So again, 1, 15, find that and plot it. 2, 30. So when I do that, it's going to look like this. Oh, look at how it looks like. It kind of looks like a curve, doesn't it? That's a really important thing you have to know because this is what we call, you know, an exponential function. That's how it looks like, okay? So then the first graph, was it linear? Yes, because it was a straight line. So was it discrete? Yes, because remember what discrete means? It means they are dots, not continuous lines, remember? So then discrete means were they just points and not a straight line? No, not that, right? So it's yes. They were actually both discrete, right? So I'm going to go ahead and put yes for this one as well. But then was the second graph linear? No. As you can see, it kind of looked like a curve, right? It kind of looked like this and like that and like that and like that. Remember that? And so we're going to say no because it was not linear. Okay? So then let's move on because this is actually the most important part, right? Not this, but the next part. The your turn question. But I don't want to do your turn question for you, so I'm going to try and pick something else. If I click on example, they give me all the answers, so I have to now try another question. So I'm going to do that. Hopefully this is not the same question. Okay. So now I want you to go ahead and copy this question. Uh-oh. There you go. There you go. All right, copy the question. Ready, go. Okay, so now that we are done copying the question, oh, actually, look at this. There was more down here, okay? So what we gotta do right now is we have to first create the table just like what we did, but it's a little bit more complicated than that. And then we gotta graph it. Okay, so let's see. This is the equation. The equation is already given to you. So what do we have to do? Well, let's take a look. Domain means x values. Okay, so all your x values are what? -4, -3, -2, -1, and 0. And we already know this because the question already has listed, they have already listed all the x values for you. And so then now in order for you to find all the values over here, they already gave you 2 answers here, right? All you gotta do is now calculate it. So when you plug in 4 into the x, what are you going to get as your answer? That's what you're supposed to put here. F of x is just a fancy way of saying y. Okay? So now let's go ahead and plug it in. Oh, hold on. Okay, so I'm sorry. All of a sudden, my children started screaming. So then anyway, let's find the negative 4. If I plugged in negative 4 in here, what am I going to get? F of x is equal to 5 times 3 over 2 raised to the negative 4 power. Just so you know, do you even know what multiplying 3 over 2 negative 4 times means? So this is an important thing, right? It's kind of like this. When I go ahead and use a different color, because this has nothing to do with solving this problem. This is just something I'm writing, okay? If you have 3 raised to the 4th power, what does that mean? You have to multiply 3 4 times. 3 times 3 times 3 times 3, right? Okay, so that's 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So 3 raised to the 4th power is 81. So we get that, but what is 3 raised to the negative 4th power? What would that mean? So I just want you to remember something. When you have a negative exponent, that means you have to flip the base, okay? Oh, there's a song, isn't it? Was it Flip That Bass? Flip That Bass. Never mind. I don't know how to sing anything. Oh gosh, no trouble. Never mind. I didn't like that song, but all of a sudden I remembered it because my daughter always sang it and I used to get annoyed. Anyhow, so this is the base, the 3, okay? And whenever you see a negative exponent, that means you gotta flip the base, okay? Flipping the base means the 3 turns into what? 1 over 3, because 3 is the same as 3 over 1. So if we flip it, we'll get 1 over 3, and then that raised to the 4th power. There's no more negative next to the 4 because we already used it to flip it, okay? All right, so now what do we have to do? We have to multiply 1 over 3 4 times. 1 over 3, 1 over 3, 1 over 3, and 1 over 3. And that will give me 1 over 81. Okay? So yeah, this had really, I'm just trying to explain to you how to solve this one right here, okay? So anyway, back to this original question. So this negative 4 exponent means what? I gotta flip that base, right? So there you go. F of x equals 5 times 2 over 3, because that I had to flip it whenever I see the negative exponent, right? And so I flipped it, and now it's going to be a positive exponent 4 on top, okay? So what does that mean we gotta do? F of x is equal to 5 times, and then we're going to multiply 2 4 times and 3 4 times, okay? Don't forget PEMDAS. We gotta do exponents first. We're not going to multiply first, okay? So if you multiply 2 4 times, that's going to be 16. If you multiply 3 4 times, it's going to be 81. Finally, 5 times 16 over 81 is the same as 5 over 1 times 16 over 18. Okay? Oh, shoot. Why did I say 18? It's supposed to be 81. Okay? So then now we just have to see if we can simplify anything, and we can't. So what's our answer? F of x is equal to 5 times 16, which is, we don't know, 이거 30, 80 over 81. Okay, so you can go ahead and put that information right here, 80 over 81. And then you'll go ahead and put that information over here too, 80 over 81. Okay, now what would happen if you plug in negative 3 and negative 1? So I'm not going to go ahead and waste your time showing you how to do all that stuff. I'm just going to pause the video and then I'll just go ahead and type in the answer for you so you can see, okay? Okay, so there you go. I paused the video and I calculated and I went ahead and put all the values here. Okay, and so what I'm going to do next is I'm going to go ahead and plot this, okay? So let's see. Let me see how they help you plot this. Oh, I don't get it. What are they doing? Do I have to like put something here? Okay, let me click on the, okay. Okay, let me see if I understood this. Okay. How do I put this on again? Oh, there you go. Here's a point. So I'm going to be at -4 comma what? Let me see. It's going to be at -4 comma 80 over 81. That's a little bit less than 1. So my x value is -4, and then, uh-oh, how come it's not moving? Oh, because I did it wrong. I'm gonna erase that. Oh, can I move it? Yes. No, I can't. No. I don't know how to use this, guys. So let me just go ahead and click, delete. Maybe I should have done click and then at -4 comma close to 1. I should just kind of like put it there. Okay. And then the next one is -3 comma 40 over 27. And if you change that into decimals, that's going to be, let's see, what would it be? I'm going to actually need my calculator. So give me a minute, I'm sorry. So 40 divided by 27, and that gives me about 1.5. So my next point is this one. Uh-oh, what have I done? Okay, so that was supposed to be at around -4 comma close to 1. Oh, they are going up in increments of 2, so close to 1. And then the next one is supposed to be like right here at around 1.5. A little bit higher. Then the next one is supposed to be 20 over 9. So 20 divided by 9 is about 2.2. Oh no, what's happening to me? Okay. So that's okay. I'm just gonna keep going really fast. Go back to that question. No, where am I? This is I am completely off. Okay, so now I'm back. Sorry, I don't know how many times I'm going to have to make bloopers while I'm recording. Oh, okay. And then of course the question changed on me. And so you know what I'm gonna do? I'm just gonna show you the answer, okay? So what you're gonna do is you're going to plug in the x values, -3, -2, -1, 0, 1. Put that in there. And then you calculate it, okay? Using the negative exponents. I already showed you how to do that. You fill it out like this. It's kind of similar. And then you plot it like that, okay? And that was it, all right? So we're just gonna move on. This is gonna be very painful for you guys trying to graph it, but still, you know, in the end, you'll get it, okay? So don't worry. And I think you have just one more question, okay? So, constructing exponential functions from verbal descriptions. So what you're going to do is now you're going to write an equation, okay? By finding, you know, A and B. What is A and B? A is when x is equal to 0. So what you're going to have to do is if there's an equation, you put 0 into the x, okay? And then the B is the number that looks like this, the common ratio, okay, that you have to multiply every single time. So there you go. We have a question that looks like this. A savings account with an initial account balance of $3,000 earns a 2% interest per month. So basically the balance grows by a factor of 1.02 each month if no deposits or withdrawals are made. Okay, so we have to try and write an equation for this question right here. So remember what they said, we have to first find an A. What is an A? The A is the original balance, and so the original balance is $3,000, so you're going to find 3,000, and that's correct. The value of B is the factor by which the balance changes every month, and they already told you that right here. So I'm going to put 1.02, and that's going to be correct. So then now you can go ahead and come up with a formula, and that would be this one right here. Okay, so now of course you're gonna be like, hey Miss Choi, what are you doing? I have no idea what you're doing. And that's okay, because when I show you the next question, it should help you. But you see, you really have to watch this video done by Mr. Berger, because he did a great job with the ladybug population. And I believe that's the only thing that we have to do. So here's your turn question. And so I'm going to go ahead and try and pick another one. There you go. So then I'm going to make it bigger for you so you can copy. I think I have to make it a little bit more bigger. Okay. And then now let's go ahead and work on this question. This is actually the easier question for today. A piece of paper that is 2 millimeters thick is folded. Write an equation for the thickness T of the paper in millimeters as a function of the number N of folds. Okay, so just remember what you learned earlier. Okay, so there was a formula, and the formula was something like this: F of N, or it could be something like T of N is equal to, it doesn't always have to be F over here. F of N is equal to, and then I'm just going to go ahead and write the equation for you in words you understand. So the first number that has to come is going to be the original amount. And it could be the original amount of anything, times, and this is the ratio or the common ratio. And then you have to raise it by the power of N. And I say N because it's N over here. If inside the parentheses was an X, then you would raise to the power of X. Okay? And so that's normally the formula.
Did you write something?
So let's go ahead and use this formula, okay, to come up with this. A piece of paper is 2 millimeters thick, and then we start folding it, right? Oh, okay, so then the original amount is what? The original amount is going to be 2 because it starts with 2 millimeters. But we're going to write T of N is equal to, not F of N, just because that's how it is over here. And they told you, write an equation for the thickness T, okay? That's why we're using T, not F, okay? Of the paper in millimeters as a function of the number N of folds. So then it's going to be 2. But then every time we fold it, it's going to increase by how much? We're going to double it, right? So then our common ratio, or the number that we have to multiply every time, is 2. Because let's think about it. If you have a piece of paper, it's difficult to explain it on the computer. So this is a good example where in the classroom, I can show you by folding a piece of paper. If you fold a paper in half, now you have double, right? But then if you fold that paper again, when you open it, you'll end up with 4. So it's basically multiplying by 2 every single time. So then your answer is 2 times 2. That's the common ratio.
Okay.
Raised to the power of N. Okay? And so that's your answer. Let me go ahead and plug it in. I'm going to put 2 times 2 to the power of N. So let's see if this is correct. I'm going to check my answer, and oh no, what happened? What have I done wrong? Hey, I did it right. So why did they say that I am wrong? I think the computer just got confused because I put the 2 in parentheses. But that is the correct answer, okay? So I apologize. It's just sometimes when you work with the computer, that's what they do. Instead of putting the times here, all I did was put parentheses around the 2, and then they said it's wrong, but it is correct, okay? So no worries. And guess what? That is it for today, isn't it? Actually, no, there is one more. Okay, so we're going to continue do the same thing. This is the formula that you have to use. So here's your turn question. Okay, so now what I want to do is just go ahead and show you how we can solve this one last kind of problem. And this is the last example for the day. I know that the video has been going on for a long time. This lesson is actually a little bit more difficult than the other two, right? So basically the question says, find the equation for the function that includes the points 1, 28 and 2, 14. So if you don't want to read, you can actually just play it like this.
Find the equation for the function that includes the points 1, 28, and 2, 14.
Isn't that cool? Okay, so anyhow, let's go ahead and try to solve that problem. And you know what I'm going to do? I'm going to go ahead and start this in a new page. Okay, so let's just go to a new page. Okay. There you go. And so basically we have to come up with an equation for a function that's 1, 28 and 2, 14. So you know what that means? There might be some other numbers before. Just because this is a 1 doesn't mean that the very first number is 28, because you can have something like 0, something, and then like -1, something. You never know what there is behind it, or in front of it, or behind it, okay? But we have to try and come up with an equation. I don't know if you remember, but just earlier I told you that the equation looks like this, okay? That's the first number times the common ratio, okay? And that's the number that we have to multiply every single time, and then it's raised to the n power. And the n is a little exponent, right? So there you go. What we're going to do is first, we're going to try and find what the common ratio is. All we know is that this one is 1 and this is a 2. Basically, these are two numbers back to back, okay? And this number comes first and then this number comes later. And so that's all we know. How do we find out? What do we have to multiply? What do we have to multiply to 28 to get 14? Well, a lot of you would know right away, oh, Miss Choi, you gotta divide by 2. But I already told you that we don't divide by 2 in geometric sequences, we only multiply. So dividing by 2 is the same as what? Multiplying by 1/2. In other words, your common ratio is what? 1/2. You're multiplying by 1/2 every single time. But we don't know what the first number is. You might be like, Miss Choi, duh, 28 is the first number because it says so. Yeah, but like I said, there could be another one, like 0, something, and then a -1, something. So we don't know for sure, right? Okay. So then this is what we have to do. If you want to figure out what the first number is, you can just plug these numbers in. And it doesn't matter which one you plug in, just plug it in. Okay, so then there you go. I think I went too far back. Common ratio is 1/2. And what I'm going to do is I'm just going to write down what I have. Okay, and what I have is f of n, that's right here, is equal to the first number, I don't know, and let's say that the first number is a, because that's what the textbook uses. And then the common ratio we know is 1/2, and then we have to raise it to the power of n. So we're almost done with the formula. What are we missing? Na. Okay, because the n is part of the formula, f of n is part of the formula. So we're just looking for the a, which is the same as the first number. Okay, so there you go. How can we figure this out? Let's go ahead and plug this in. This is an x value and this is a y value, right? So instead of n, I'm going to put in 2. Okay, Because you know, this is n, I'm sorry, this is n and f of n. And then instead of f of n, I'm going to plug in 14. So now let's go ahead and rewrite this. 14 equals 8 times 1 over 2 raised to the second power. We know what that means. We have to multiply 1 over 2 times. So 14 is equal to a times 1 over 2 times 1 over 2, which is 1 over 4, right? So then I'm going to go ahead and continue over here. So 14 is equal to 1 over 4a. Because look, it's 8 times 1 over 4, which is the same as 1 over 4a, right? If I want to find out what a is equal to, what do I have to do to both sides? This is kind of like a over 4, like a divided by 4. So to find out what a is equal to, we got to multiply 4 to both sides. So a is now equal to 14 times 4. And that gives me 64. So then now that I know what my a is, am I ready to now finish my equation? Yes, I am. Because now I have the common ratio, which is 1/2. And what is my first number? I just figured it out. It's 64. Now I have my common ratio, my first number, and everything else is the same. So what is my formula? For the equation or the function that passes through these 2 points? Well, it is f of n equals the first number, which is 64, times the common ratio, which is 1/2, raised to the n power. Now let's go ahead and check if this is correct, okay? So blah, 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 blah. Wait. Where's the equation? Blah, blah, blah. And then if you didn't understand anything Miss Choi said, you can go ahead and follow all these steps because it's right there. And look, my answer is correct. And so that's it. You can go ahead and work on your question here, but I don't know what I did. I kind of cheated. And so I already got the answer. So that's it for today. When you come to class, I know that you're still going to be confused, especially regarding the question on graphing. Okay, so what I'm going to do when you come to class, I think we're going to just work on graphing. Well, not really. We also have to work on coming up with an equation. But anyway, this is the ticket out the door, or something that we're going to be working on tomorrow in class when you walk in. So I just wanted to show it to you. There you go. So this is the question that I want you to complete tomorrow before you leave, and this is the graphing one, okay? You have to plug all this in, calculate, make a table, and then you have to do that. The best thing is you already have a calculator that you can use, so this is not going to be that difficult. Okay, so that's it. Well, the most important thing today that you have to know is that you know, geometric sequences, they end up being exponential functions, and exponential functions, when you graph it, they kind of look like that, like a curve going up, okay? And so it looks like this. And again, these dots are discrete functions, and if it's a straight line, it's a continuous function. All right, I'll see you tomorrow. Goodbye.